Alright, this graphing lesson will continue moving into systems of equalities. Now when you're graphing a system of equality, the solution, what we're after, is the point where the two lines intersect. This is the point, the xy value, that makes them both true. So three different things can happen. You can have one solution because your lines intersect in one spot. You can have no solutions, which really means you have parallel lines, or you can have infinite solutions, which means you have the same line. When you graph it, the lines overlap. So the first thing we always have to do is go ahead and graph. So this is already in slope-intercept form for me. Y-intercept is 2, my slope is -1/4, down 1, right 1, 2, 3, 4. Up 1, 1, 2, 3, 4. You've noticed I like to graph with 3 points. 2 is all that's required, but I draw a little straighter lines when I have 3 points. So my orange line here has a y-intercept of -1 and a slope of -1/1. Down 1, right 1, up 1, left 1. And I'm going to follow that one up just a little bit because I could better see that this point right here, which is at -4, 3, is my solution. And that's what I'm after. If I go ahead and solve this first one, put it in slope-intercept form, I have -2y is equal to -x plus 2. Divide both sides by -2. I have y as 1/2 x minus 1. If I solve the second one, -2y is equal to -x plus 8. Divide both sides by -2. I have 1/2 x minus 4. At this point, if I remember, I know these lines are parallel because they have the exact same slope, and I know there will be no solution because I have parallel lines. But let's go ahead and just graph it for fun to make sure we see what's happening. I have -1 and I have up 1, right 2, down 1, left 2. There's my orange line. Go ahead. Here's my purple line, has a y-intercept of -4. It goes up 1, right 2, down 1, left 2. And as you can see, those lines will never intersect. Now, when we're looking at the solutions of an inequality, remember inequalities, half of the graph makes a solution. So what we're going to do is we're going to look for the overlap where both are true. And it's going to be the entire region. But again, we can have a solution region where they overlap. We can have no solution, parallel lines shading away, or we can have all real numbers, basically the same line shading both sides, or some sort of overlapping lines that shade everything in the whole graph. So these two lines happen to already be in slope-intercept form. So I'm going to graph them like they were lines. It's less than or equal to, so I have a straight line, solid line. I'm going to go ahead and test with 0, 0. So is 0 less than or equal to -0, which doesn't make sense, over 2? Is 0 greater than or equal to 2? Well, that's false. So I shade everything opposite that test point, and I'll go ahead and make my 0, 0 that color. Now I'm going to do this one in blue, -3, and I go down 1, right 1, up 1, left 1. Before I even got going too far down the line, I notice I have parallel lines. When I go ahead and test my blue point, 0 less than or equal to -0 minus 3, is 0 less than or equal to -3? No, that is also false. And so I shade this side, and this one becomes no solution. If I jump over to the next graph, I do not have parallel lines this time, so I have y-intercept at 3, a positive slope of 1/2, up 1, right 2, down 1, left 2, a less than sign, and so this is a dashed line. If I go ahead and test with 0, 0, I end up with 0 being less than 3, which is a true statement, which means that I'm going to shade everything on this side. Notice I'm not going to shade it super dark, but I'm just going to make enough of a mark that I know which side. So here I have -1 with a slope of -3/2, so I'm going to go down 3, 1, 2, 3, right 1, 2, or I could go up 1, 2, 3, left 1, 2. This is a solid line. And when I test for this point, 0 less than or equal to -3/2 times 0 minus 1 is 0 greater than -1. That is also true, so I shade the side that includes 0, 0. Now what I have is I have this region where the blue and the orange overlap, and I'm going to go ahead and I'm going to darken a straight line and then a dashed line and darken this area right here. So we will continue with the next example here. I need to solve these for y, so this is going to be the one I'm going to do in green. So y is greater than -5x plus 3, and so I go to 3, I go down 5, 1, 2, 3, 4, 5, right 1. It is a greater than, and so I need to do a dashed line. If I go ahead and test my original with 0, 0, is 0 greater than 3? Well, that's a false statement, so I shade the side away from 0, 0. Go ahead and grab a different color. I'm going to solve this one in red, and so I have y is greater than -x minus 1. So my y-intercept is -1. My slope is down 1, right 1, 1, right 1. This is also a dashed line. If I go ahead and test my original, 0 plus 0, is that greater than -1? Well, 0 is greater than -1. That is true. So I shade the side that includes 0, 0. The region where my red and my green overlap, dashed line to this point, dashed line to that point, and darken in this overlap area. And you do need to darken in the overlap area so it's clear that you know what the answer is. Last example. -3y greater than or equal to -x minus 6. I'm going to divide by a negative, which means I have to flip my inequality sign. And so I go ahead and graph that at 2. I go up 1, right 3, or I go down 1, left 3. This happens to be a solid line. And if I test my original with 0, 0, is 0 greater than or equal to -6? That's a true statement, so I'm going to shade the side that includes 0, 0. In orange, I'll go ahead and say that y is greater than -x minus 2. Here's -2. I have a slope of down 1, right 1, up 1, left 1. This happens to be a dashed line. And if I test the original, 0 plus 0, is that greater than -2? That is a true statement. So I shade the side that includes that. So my overlapping region would be dashed line going down this way, solid line here, and darkened in this area. And that is the end of the graphing lesson.